Hey everybody. Today what we're going to walk through is an introduction to sequences. We're going to take a peek, see what they look like, and some introduction to some terminology that you guys are going to be responsible for. What you see on the screen right now is a couple quick little patterns. These are sequences. And what I'd like you to do for each one of those patterns, just take a moment and I want you to try to predict the next term. Okay, so for each one, I want you to go through and fill in that blank, that missing spot. Okay? Pause the video now, give it a shot. Okay, we're back. So maybe we're taking a peek at the first one and we notice that we happen to be adding 4 to each term. And that was our pattern. And that enabled you to go, hey, I think that next spot would be 19. Maybe in the next one, we were taking a look and we said, hey, it looks like I'm multiplying by 3 on each term. And so as I multiply by 3, now we got a little bit extra work to do, but hopefully we came up with 162 in that spot. And the last one happens to be a bit of a favorite. It's a famous one. If you happen to know the name of it, it's called the Fibonacci sequence. And what it is each term is made up of the sum of the 2 previous terms. So you'll notice this term that I'm underlying here is made up of the 2 previous terms being added together. If I then was to take a look at the next term, I would notice that 3 was made up of 1 plus 2. And if that pattern continues on, where we take the 2 previous terms and we add them together, then the way I get that blank spot, that open spot, would be to take the 2 previous terms and find their sum, and hopefully we came up with 13. Okay, those were just 3 quick problems for us to go through to get a sense of what a sequence looks like. I've already used some of that terminology today already. What I want to do is make sure that we are good with the way some stuff looks and some vocabulary that goes with it. So let's move on. What you see on the screen right now is some terminology, some notation. You'll notice in the top bullet, each sequence is made up of terms, and you've already heard me use that terminology today. The way we denote that, you'll notice in red. So we use subscript. So you'll notice what I'm highlighting in blue, we would read that as term 1. And each one of those terms are separated by a comma. So you'll notice that we have a comma in between our 2 terms. And so if I was to read that list of red terms, I would say it's term 1, term 2, term 3. And then when we see our ... that's just saying that there is some unlimited number of terms or unstated number of terms. It doesn't mean that there are infinitely many terms. It could, or it could also mean that there's just an unknown number of terms. And then our last term, which you guys see highlighted in blue, that is a T with a subscript N. You can call that term N, or you can also refer to it as the nth term. Okay, the other piece of terminology you would be responsible for is the phrase general term. You'll be asked to come up with a general term for a sequence. And we need to know that a general term is simply a rule or an algebraic expression, which is a fancy way of saying an expression or an equation. And it's used to generate the terms of a sequence, or when we get into something called a series. Okay, I want to take a peek at some of that stuff more in action. Okay, let's move on. So there is a lot of information on your screen right now. You can see at the top, I've given a little example, a sequence for perfect squares. And in red, you'll notice that I started to list out our perfect squares. 1, 4, 9, 16, and so on and so on. If I was to use my terminology, I want you to focus with my notation on what I just highlighted in red. And I need you to see the location of the term number that you see in green and the term value that you see in orange. That notation is going to be super important for us. So the term number is 2, and let me just get rid of that for a second. But my term number is 2, so the second term, and I would say the second term in the sequence is 4. That's the value. So we're going to be responsible for being able to tell the difference between a term number and the value, the actual number in the sequence. So you can see all that notation in blue. And then you'll see in purple, if I was to create the general term for that sequence of perfect squares, it would be n squared. And the way that we would actually write that, we would write it as an equation. It almost looks like a formula. I could write it in term notation. So you'll see what I just highlighted in green. There is my term n, or the nth term, equals n squared. Or we can bring back some of that function notation that we addressed earlier in the year. That's another common way for us to see sequences. I could say f of n equals n squared. Now, why do both of those represent our general term? Because if you notice, if I make the substitution of 1 into that general term, then that would tell me replace my n with 1. If I replace one of my n's in a formula, I have to replace all of my n's with that value. You'll see the same thing in the next. To generate the second term means I have to sub 2 in. To generate the third term means I have to sub 3 in. To generate the fourth term, I sub 4 in, and so on and so on. And so the expression n squared allows me to calculate each term in the sequence. You'll see that also when you take a peek at your function notation, because we could represent a general term in that form. And then at the very bottom, I don't know if I could tell you guys a more important thing right now in terms of generating sequences. There is no such thing as term 0. When you have a list of values in a sequence, then the first term is always term 1. You can't begin with like a term 0. There would be nothing in that sequence. Okay, that is a lot of terminology. It's a lot of notation. What I want to do is I want to spend some time playing around and using it so you guys can see and get more comfortable working with that notation. Let's jump into the next problem. Here's our question 2, and what I would like you to do is determine the first 3 terms of the sequence given by the general term, so given by term n equals 5 to the exponent n minus 1. Okay, we're still new to a lot of this terminology, but I think you guys would be comfortable to be able to give it a shot. So what I want you to do, pause the video and try to come up with the first three terms of that sequence. Okay, pause it now. Okay, we're back. So I am hoping that we were able to say, well, if I need the first 3 terms, then that means I need the first term. So for me to go through and try to find term 1 means that I have to replace my n with a 1 in my general term. Now, you probably didn't write that down. You just took a look at it. And I'm hoping that we were able to simplify that to 1. You then would have found the second term by subbing in a 2 wherever I see the n in my general term. You simplify it. I'm not going to write 5 to the exponent 1. You then have to determine the third term given the instruction. So I'm going to replace my n with 3. Now I can simplify that. There we go. There's the first three terms. Your response would be this, that it would be 1, 5, 25. Now, you can do this and state that that sequence would continue, but given the instruction to just determine the first three terms, you would be fine to simply state the first three. Now, this is a pretty direct question, so I have to be very fair on here. If I was to ask you something like this on an evaluation, which I probably wouldn't, but if I was to ask you something like this, you would never have to show me any of this work in between. That could all be done mentally, and you could simply state your final answer, the first three terms. Okay, hopefully that went well. You guys were good to be able to use a general term to create terms in a sequence. Okay, let's play with something a little different. What you now see on the screen, I'm going to give you some time to work through. Here are 5 sequences, and I want you to go the other direction. So if I give you the sequence, can you go back and can you create the general term? So I want you to play with these. This is going to be a series of, hey, let's give it a shot. As soon as you think you are comfortable, then pause the video and try them on your own. So let's everybody start with problem A. I want you to take the sequence 101, 102, 103, 104, so on and so on and so on, and I want you to try to create the general term for it. Okay, give it a shot, pause the video now. Okay, we're back. So you take a peek at that sequence, and we could have had a tough time doing it. Sometimes what ends up happening is you guys get so focused on what the pattern is that we struggle to create the general term for it. But we have to be very focused on the pattern. So I am hoping that even if you didn't write this, there was some level of you were adding 1 to each term. Okay, so now how do we create the general term for it? We could have said, hey, well then I've got term n. Well, my first term is 101, and so I'm just going to add 1n to it for every term. So let's say I come up with that as my general term. I'm going to test it out. I'm absolutely going to test it out. So for me to test it, what I can do is I can go on the hunt to try to find term 1. Well, term 1 says I replaced my n with 1, therefore I have to replace all my n's with 1. 1 times 1 is 1, that got me 102, and my problem is that's not term 1. That's term 2. So I made an error with my general term. Okay, I'm going to erase that whole thing because I know that it's wrong. But as we are searching our way through, there will be a level of guess and check. One thing that can help is knowing that we don't have term 0, but searching for kind of like a starting value. Notice I was 1 too many when I tried the general term you see. So if I maybe back it up a little bit, and instead I said, well, if I start at 100, and then I add 1n to everything, then maybe that'll generate my term, my sequence. And if I take a peek, what I mean by back it up is I'm almost going, well, then I'm going to subtract 1 to go the other way. Again, I don't have term 0, but I'm kind of looking for a starting point. And if I was to now test, I'm going to say to look for term 1 means I need to sub in 1 wherever I see my n. That gives me 101. I'm on the right track. I would not only test that though. I'm now going to do the same thing and test term 2. That means replace my n with a 2. I see that I get term 2 in my sequence, and I'm feeling super confident. You can do a mental check on the rest, but as soon as you start to get the hang of it, I think we're good. Okay, there was a walkthrough on A. Now what I want you to do is try the rest. So pause the video as soon as you are feeling comfortable to do them on your own, give them a shot, and then you can unpause and we can see how we match up. Okay, pause it now, give them a shot. Okay, we're back. So I am going to walk through B. Well, I take a peek and I can notice I could do the same thing and say, well, I'm adding 2, and I'm adding 2, and I'm adding 2. So there's my pattern. And then what I can do is I realize that if I said, well, if I was to back up and go -2, it would get me to a 0. So I would almost be motivated to say that, like, my starting value was 0, and now I need to add on 2n, 2 times my term number. Now, clearly, I'm not going to write 0 plus 2n, because that whole thing would then just reduce to 2n. And if we do a quick check, you can see that term 1 is 2 times 1, term 2 is 2 times 2, and so on, and our pattern works out. Now, for some variety, I'm going to start to now use function notation as well, just to make sure that I'm comfortable with both notations. Okay, I think we should be good to be able to pause it and give the next 3 a go. So when we come back, we'll check the following 3 sequences. Pause it now. Okay, we're back. So if I take a peek on C, I can notice that I'm adding 5 to each sequence. That pattern continues. If I back it up from 6, I notice that I can get to a value of 1. And so for some variety, I could now say that f of n is going to be that starting value of 1 plus 5n. And obviously, you could have given, in the other form, n1 plus 5n is the same as 5n plus 1. Both are good. You do a quick check, and maybe now what I'm going to do is I'm going to check something down in the sequence. So what I mean by that is, like, I'm going to pick a term in that sequence that's not one of the first terms. So, like, I'm just going to kind of test 26. If I count it out, that would be term 1, 2, 3, 4, 5. So I'm going to use as my check, what would term 5 be? That means if I replace my one n with a 5, I have to replace all my n's with a 5. I do a quick check, 25 plus 1, there's my 26. Yes, I match up. I am super confident. Okay, let's take a look at D. D, I notice that I am tripling everything. I am always multiplying by 3. And so if I was to go through, then I notice that my term value is always 3 times my term number. I could do a check, I take a look, and I chest out, hey, my 81. Well, that would be term 4, so now I check out f of 4, and I get 3 times 4, and that's 12, and I go, oh no. That does not match up. Okay, then I know I goofed up on my general term. Okay, I back it up, and I say 3n clearly isn't the value. Oh, but they all look like they're powers of 3. And now I do my check, and I say, okay, so term 4, that would be 3 to the 4th. Now, 81, yep, there I match up, and I'm good. Okay, my last one. I take a peek. Well, I'm adding 3, then I'm adding 5, then I'm adding 7, then I'm adding 9, and I started to write multiplies in there. So I noticed that I have a little bit of something different in my pattern. I am not changing the same way from term to term, but I can clearly see what a pattern was. And we should be good that we could predict what the next term in that sequence would be. Looks like we would be adding 11. So the next term I would get would be a 35, and so on and so on. Okay, what could I do for that in terms of a pattern? Well, I take a peek and I notice that maybe if I was to write out, that's term 1, that's term 2, that's term 3, that's term 4, that's term 5. I'm starting to take a look at what's happening to my term number that gets me to the term value. And so when I sub in a 1, I have to get a 0. Well, I could multiply 1 by 0. But if I multiply it by 0, then every value in my sequence has to be 0, and that doesn't work. I could subtract something from 1 to get to 0. I could take off 1. Well, then when I take a look at my 2, well, I wouldn't subtract that, and my 3, I wouldn't subtract. So now I have to start think, how could I affect my term number? And maybe we can start looking at that sequence and saying, well, term 1 was 1 subtract 0, or 1. Term 2, what could I do to 2 that I could subtract 1 from it and get 3? Well, what number would I subtract 1 from to get 3? That would be 4. What can I do to 2 to get to 4? Okay, if I subtract 1 from a number, I get 8, then that number would have to be 9. Subtract 1 from something, I get 15, that number, and all of a sudden I start to notice, wait a second, I have my perfect squares. And maybe then I can determine, okay, my pattern, my general term would be take my square, my term number, and square it, and then subtract 1. I can test that out on any of my term values, and I go, hey, look, that one works. Now, as we examine that, there's going to have a huge feel of guess and check. And I'm going to tell you, don't you worry. We're going to have some strategies that are going to get us there a little more directly than that. But big picture, maybe we can see, I actually could have kind of told in my background that could have been quadratic. And if you guys think back to your step method, that is, when we go through and we examine the values of our parabola, we may notice what I have in highlighted in green, my red writing, that's the pattern as I move point to point on my parabola. Over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7. There is my step pattern on my parabola. That could guide us a little more to say, hey, I need something squared. Okay, you have some practice right now, just playing around with general terms. It's okay if it feels like guess and check. It is totally fine. Okay, I want to introduce you to one last piece of terminology. You take the screen now, and what I've put on the screen is something that's referred to as a recursion formula or recursion formula. Those are the two ways to talk about a sequence that depends on previous terms. So I'm going to highlight in red right now, there is the general term for your recursion formula. And you'll notice that what that says is term n is equal to term n minus 1 so the term that came before it, plus 2 times term n minus 2, the term that came 2 before it. Okay, now we get some details where term 1 is equal to 1, and term 2 is equal to 5, and n has to be bigger than 2. Your responsibility, go through and determine the first 5 terms. Okay, we've already been given term 1, and we've already been given term 2. And we've been told that n must be greater than 2. Now, I just want to take one moment to talk about why this n has to be greater than 2. So one of the ways we can check that is, let's not follow that. Let's break it and see what problem arises. Well, let's imagine that we said n equaled 2. Well, then my term number would be 2. I allow n to equal 2. Therefore, all of my n's have to equal 2. And now when I simplify all of those operations, I get term 2 is equal to term 1 plus 2 times term 0. And that should be screaming at us right now for what the problem was, because we know we cannot have a term 0. So I'm hoping that you can see why it requires that restriction that n has to be greater than 2. If n is ever not greater than 2, we end up getting a term that is term 0, or a term that is term, I don't know, 1, or term -1, or term -2. Okay, I can't have a term -1 in a sequence that is a list of numbers. I can't have a negative place in a sequence. So that restriction is there to just make sure that all of our term numbers remain positive. Okay, I think you should be good to be able to give that one a shot. Give it a shot, we'll come back and we'll see how we match up. Okay, we're back. I'm hoping that then the first thing we're looking for is term 3. And to find term 3, we need term 3 minus 1 plus term 3 minus 2. Of course, you could have just written down that that was term 2 plus 2 times term 1 and simplified it right in one go. You see in the given information that you were told that term 2 was 5 and term 1 was 1. That allows you to calculate that term 3 was 7. If you're going to come up with the first 5 terms, then we need 2 more terms. The problem gave us term 1 and 2. We just figured out term 3. We need to find term 4 and term 5. So if that red helped you out, then pause the video, finish it off. We'll make sure we match up. Otherwise, we're checking our solution. For us to find term 4, that means that I need term 3 plus 2 times term, yikes, term 2. And so that's going to give us term 3 that we just found, being 7, and 2 times term 2 being 5, that's going to get us up to 17. Our last check, we would then have to find term 5. That would be term 4 plus 2 times term 3, which would be 17 plus 2 times 7. There is your 17 plus your 14 and a 31. So finish off the problem. Therefore, my first 5 terms would be 1 and 5. Those were given. 7, 17, and 31 I just found. Okay, Today's topic was a lot of vocabulary. It was a lot of terminology, some notation. This is where we're going to go for this upcoming unit. So I'm hoping that this gave you a good opportunity to get introduced to that. You play around with some of your practice. And then, as I said, if there's an element of guess and check to what you're doing today, that's okay. We'll narrow it down a little bit as we move forward. Okay, jump in and get some practice. Good luck.